Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces. Today we're talking about something that affects all of us, software bugs.
Right. If you've ever had an app crash, a website freeze, or your computer just do something weird and unexpected, you've met a software bug. They're a constant headache for developers who spend a huge amount of time trying to find and fix them before they reach us.
Exactly. And the way they usually do that is through testing. For example, if you build a calculator app, you might test it by typing in 2 plus 2 and making sure the answer is 4. This is called example-based testing. You give it a specific example and check for the specific correct output.
But there's a problem with that. What if your calculator works for 2 plus 2 but breaks for 2.1 plus 2.2? Or for negative numbers, or for really, really big numbers? The developer has to think of every possible weird scenario, and that's basically impossible.
This is where the paper we're looking at today comes in. It's called Agentic Property-Based Testing, Finding Bugs Across the Python Ecosystem, and it explores a much smarter way to test software using AI.
Okay, so let's break that title down. Property-based testing, what's that?
Instead of checking specific examples, you check general rules or properties that should always be true. Let's go back to the calculator. A property of addition is that A plus B is always equal to B plus A. It doesn't matter what A and B are.
I see. So instead of testing 2 plus 3 equals 5, you tell the computer, hey, check if A plus B always equals B plus A, and then the computer just throws thousands of random numbers at it to see if the rule ever breaks.
Precisely. Another great example is data compression. A property of any good compression tool is that if you compress a file and then immediately decompress it, you should get the exact original file back. You don't need to know what's in the file, you just need to know that this round-trip property holds true.
That sounds way more powerful. You could find bugs you would never have thought to look for. So why isn't everyone doing this all the time?
Because coming up with those properties is the hard part. For a simple calculator, it's easy, but for a complex piece of software with thousands of functions, figuring out the essential universal rules that should never be broken takes a lot of time and deep expertise.
Okay, so that brings us to the agentic part of the title. I'm guessing this is where the AI comes in.
You got it. The researchers created an AI agent using a large language model. Think of it not just as a chatbot, but as an automated software tester. Its job is to do all the hard work that a human developer would normally do.
So what does this AI agent actually do? Does it just read the code and guess?
It follows a very systematic 6-step process. First, it analyzes the target software. Let's say a specific library in the Python programming language. It reads the code, the documentation, the comments, everything it can to understand what the code is supposed to do.
Okay, so it's doing its homework.
Step 3 is the magic part. It proposes properties to test. Based on the documentation, it might say, this function claims it always returns positive numbers. Let's make that a property to test. Or, this function sorts a list. A good property would be that the output list should have the same elements as the input list, just in a different order.
And once it has a property, it moves on to step 4. It actually writes the code for the property-based test. Then step 5, it runs the test, hammering the function with tons of data to see if the property ever fails.
And if it does fail, if it finds an input that breaks the rule, it moves to the final step. It tries to figure out if it's a genuine bug. If it is, the AI agent writes a complete, detailed bug report, including a summary of the problem, the code that found it, and even a suggestion for how to fix it.
That's incredible. It's an end-to-end bug hunter. So the big question is, did it work?
It worked spectacularly. The researchers unleashed this agent on 100 of the most popular and widely used Python packages in the world, software that powers everything from data science to web servers, used by millions of people.
And it found bugs.
It found tons of them. The agent generated nearly 1,000 bug reports. The researchers manually checked a sample of them and found that over half were valid bugs, and about a third of them were serious enough that they felt they should be reported to the software maintainers.
Can you give us an example? What kind of bugs did it find in these super popular libraries?
Some of them are fantastic. It found a bug in NumPy, which is the absolute cornerstone of scientific computing in Python. There's a function that models a specific statistical distribution, which, by definition, can only produce positive numbers. The agent discovered that if you gave it very large inputs, it would sometimes produce negative numbers due to a numerical precision error. That's a huge deal. It's like a calculator saying the square root of a positive number is negative.
Wow, okay, that's a genuinely subtle but important bug. What else?
It found a bug in a library from Amazon Web Services. A function was supposed to slice a dictionary, a data structure, into smaller chunks. But the agent found it was just returning the first chunk over and over again. So if you asked it to slice a pizza for you, you just get the first slice handed to you repeatedly.
That's pretty funny and definitely not what you want.
And one more. In a popular date and time library, it tested the function that calculates the date of Easter. It found that for certain years in the future, the function would return a date that wasn't a Sunday or was in May. Both are impossible for Easter. The agent found this by creating a property. The output of the Easter function must be a Sunday in March or April.
So this isn't just a theoretical exercise. The AI found real bugs in real software, and the researchers actually reported them.
They did, and several of the bugs they reported have already been acknowledged and fixed by the developers. An AI found a bug, wrote a report, and that led to a human fixing the code.
That's amazing. So what's the catch? Are there any limitations here?
The main one is that the AI can sometimes get confused between a real bug and an intentional but weird design choice. It doesn't have the full context a human developer might have. Also, this process isn't free. The researchers calculated that each valid bug cost about $10 in computing time to find.
But they argue that's an upper limit, right? A human would be able to direct the agent more intelligently, so you'd waste less time and money.
Exactly. The big picture here is really exciting. This paper presents a new way to think about keeping our software secure and reliable. Instead of relying solely on overworked human developers to manually search for bugs, we could have fleets of these AI agents constantly and automatically auditing our code, finding problems we never even knew we had.
It's like having a tireless, super smart assistant who does the most tedious part of your job for you and does it better than you could. A powerful tool for developers, but it also makes you think about the flip side. It could also be used to find security vulnerabilities.
That's a point the authors make as well. Like any powerful technology, it has dual uses. But as a tool for making software better, this is a massive step forward. It's a glimpse into a future where our apps and websites might just crash a whole lot less.
And that's a future I think we can all get behind. That's all the time we have for today. Join us next time on Daily Papers.